So let's take a look at derivatives of logarithmic functions. Now these will basically be the last set of derivative formulas that we need to know. So starting off with the first one here, we have the derivative of log base a, and a is just a constant, a certain number, of u, some inside function. So u can be x, it could be x squared plus 5, it could be x to the 7th. It doesn't matter what it is, but the general formula you can use is going to be u prime over u times the natural log of a. And the way I memorize it is just by saying u prime over alna. So for the next one we have the derivative of the natural log of x. And this one's pretty easy. Derivative of natural log of x is just going to be 1 over x. Now let's say instead of natural log of x we have the derivative of natural log of something else. Like it could be x squared plus 5, it could be ln of sine of x. You know, whatever it is, the general formula we use is 1 over u times u prime. And so that will end up being u prime over u. This is the general formula you use for natural log of basically anything. So notice the formula for a derivative of ln u is very similar to derivative of ln x, just that because we have an inside function u, something other than just x, we have to multiply by u prime, or the derivative of that inside function, because of the chain rule. Now the next video in the playlist, or the next video that I will do, is going to be a derivative rules video. So I'll basically make the formula, or I'll basically write down the formulas for all derivatives that we need to know for Calculus 1. Now this might not come back to you until maybe Calculus 2, but the irrational number e, around 2.718, described as a limit, is going to be equal to the limit as x approaches infinity of 1 plus 1 over x, the entire thing raised to the x power. An alternative limit for e can also be the limit as this time x approaches 0 of 1 plus x raised to the 1 over x power. So for number 1, let's go ahead and find the derivative of f of x equals ln of x squared plus 10. So because we have an inside function here, x squared plus 10, we have to use the formula where we're going to take the derivative of the natural log of some inside function u. Once again, the formula is going to be u prime over u. So in this case, if our x squared plus 10 is u, let's go ahead and use this formula. So u prime, or the derivative of x squared plus 10, is just going to be 2x. So f prime of x equals 2x in the numerator, and then over just u itself, so just the inside function itself, so 2x over x squared plus 10. And that's the final answer. Now for number 2, we have f of theta equals ln of cosine theta. Realize cosine theta is our inside function. So once again, the derivative of ln of some function u is going to be, we take the derivative of the inside function over the inside function itself. So if cosine of theta is our u, derivative of cosine theta is going to be negative sine theta over the inside function itself, so over cosine theta. Now sine theta over cosine theta is tangent theta, so then we get f prime of theta equals negative tangent of theta. Now for number 3, we have f of x equals log base 2 of 1 minus 3x. So once again, the formula for the derivative of log base of a, which is a is some constant, of some function u, is going to be equal to u prime over alna, or u prime over u times the natural log of a. So in this case, our a, or our base is 2, our u is going to be 1 minus 3x. So let's go ahead and use the formula. So u prime first, now f prime of x equals, the derivative of 1 minus 3x is going to be negative 3, over u, which is just 1 minus 3x, our inside function, times ln of our a, which is our base. In this case, 2 is our base, so we have ln of 2. And that's the final answer. So now for number 4, we have f of x equals the 5th root of the natural log of x. So the very first thing I would do here in this case is try to put the function in exponential form. So in this case, I'll rewrite it as ln of x, the entire thing to the 1/5 power. Because now what I can do is go ahead and use the power rule combined with the chain rule. So our inside function is ln x. It's being taken to the 1/5 power. That's the outside function. So when we use the power rule combined with the chain rule, f prime of x, the derivative, is going to equal, now I bring the power down, keep the inside function the same, subtract the power by 1, so 1/5 minus 1, or 1/5 minus 5 over 5 is negative 4 over 5. And then we can go ahead and multiply by the derivative of that inside function. Now the derivative of ln x is 1 over x, so let's go ahead and multiply by 1 over x. And so simplifying here, we get ln x, the entire thing to the negative 4/5 power, over, we do have 5 and x, so multiply, we get 5x. Now because we do have a negative exponent, I'll bring that to the denominator as well. So then we get 1 over 5x times ln of x to the 4/5 power. And that's the final answer for f prime of x. Now for number 5, we have f of x equals the square root of x times ln of x. Because we do have two functions being multiplied to each other, we do have to use the product rule. So once again, when we use the product rule, f prime of x equals, we take the derivative of the first function. So derivative of square root of x, well, we can use the power rule here. We change square root of x to x to the 1/2. We bring the power down. So 1/2 x to the negative 1/2 because we subtract the power by 1. So that can also be written as 1 over 2 times the square root of x. So derivative of square root of x is 1 over 2 square root of x. So we take the derivative of the first function times the second function unchanged, so just times ln x, plus the derivative of the second function, derivative of ln x is 1 over x, times the first function unchanged, so just times the square root of x. Now simplifying here, we do get ln x over 2 times the square root of x, and then plus square root of x over x. And that's the final answer. So now for number 6, we have f of t equals ln of this entire thing. So 2t plus 1 cubed over 3t minus 1 to the 4th. Now there are a couple different ways to go about this. So the first way, you can obviously just use the formula, where derivative, once again, of the natural log of some inside function u is going to be u prime over u. However, that's going to take a while because in order to derive the inside function, we do have to use the quotient rule, and then we have to divide it by the entire inside function itself. So the easier way is going to be using properties of logs to actually split this up. Now, if you have the natural log of some term a over another term b, you can go ahead and split this up into ln of a minus ln of b. So the same exact thing works here. We can go ahead and split this up into ln of the top function, so 2t plus 1 cubed, and then minus ln of 3t minus 1 to the 4th. Now another property of the natural log is, let's say you have the natural log of, let's just say the variable x raised to a power a. You can actually go ahead and bring that power in front of the natural log and rewrite it as a times the natural log of x. If we do that in this case, it'll be much easier to find the derivative. So in this case, f of t equals, we bring the 3 in front of the log, there's going to be 3 times the natural log of 2t plus 1, and then we have minus, we bring the 4 in front, and say 4 times the natural log of 3t minus 1. So now we can go ahead and differentiate. So f prime of t equals, now I'm just going to go ahead and erase some of this stuff and then move what we have over. Now because we do have a minus here separating both of these terms, we can go ahead and take the derivative of them individually. So let's go ahead and first take the derivative of 3 times the natural log of 2t minus 1. Now 3 is a constant, so we can rewrite it as 3 times the derivative. This time the variable is t, so we have to derive with respect to t of natural log of 2t plus 1. Once again, the derivative of natural log of some function u is going to be u prime over u, or in other words, take the derivative of the inside function and divide it by the inside function itself. So we have 3 times the derivative. Now if 2t plus 1 is the inside function, then u prime, or the derivative of that, is 2 over the inside function itself, so 2 over 2t plus 1. If I go ahead and multiply, 3 times 2 is 6, so we get 6 over 2t plus 1. So that is going to be the derivative of 3 times the natural log of 2t plus 1. And then we have minus the derivative of 4 times the natural log of 3t minus 1. We can go ahead and rewrite that as 4 times the derivative. With respect to t, once again, that's the variable, of natural log of 3t minus 1. So we have 4 times the derivative. So once again, in order to take the derivative of natural log of 3t minus 1, we take the derivative of 3t minus 1, which is 3, the inside function, over the inside function itself, so 3t minus 1. We go ahead and multiply. 4 times 3 is 12. So the derivative of 4 ln of 3t minus 1 is going to be 12 over 3t minus 1. And that's going to be the final answer. Now for this next problem, we have to use logarithmic differentiation to find the derivative of the function. So for number 1, we have y equals x raised to the power of sine of x. So we're going to do exactly what it says. Logarithmic differentiation, we're going to use logs to derive. Now notice our function here. It's a function raised to another function, x to the power of sine of x. And we don't have the derivative formula for x raised to the power of x, or x raised to something other than x, like u, or in other words, a function raised to another function. But what we can do is use logs to be able to make this easier to derive. So the very first thing I would do is natural log both sides of the function. So we have natural log of y equals natural log of x raised to the power of sine of x. Now, similar to the previous problem, using properties of logs, we can bring that sine of x in front of the natural log. So then we get the natural log of y equals sine of x times the natural log of x. So now what we have to do, the next step here, is to use implicit differentiation. So remember, in implicit differentiation, we're going to derive both sides of the equation with respect to x, so d over dx. Now remember, we have derivative of natural log of y on the left side of the equation. And derivative of natural log of y is just going to be 1 over y. But because we derived the y with respect to x, because those are two different variables, we have to multiply by dy dx, or y prime. So now that's going to equal the derivative of the right side of the equation. Now because we do have two functions being multiplied to each other, we have to use the product rule. So in the product rule, once again, we take the derivative of the first function, which is cosine x, times the second function unchanged, so times ln x, plus derivative of the second function, derivative of ln x is 1 over x, times the first function unchanged, so times sine of x. So now I'm just going to go ahead and simplify. So on the left side of the equation, we get y prime over y equals ln x times cosine x, and then plus sine of x over x. So now the last thing we have to do is to solve for y prime, because y prime is dy dx, dy dx is the derivative, and that's what we're trying to find. We're trying to find the derivative of the function. So when I go ahead and multiply both sides by y, we get y prime, that's going to be isolated now, equals y times ln x cosine x, and then plus sine of x over x. Now our answer right now is both in terms of x and y variables, and it's better if we can just put it in terms of x variables. So remember, in the beginning, our function y is equal to x raised to the power of sine of x. So I can go ahead and replace that for y. So the final answer, y prime dy dx, or the derivative, is equal to x to the sine x times ln x cosine x plus sine x over x. And that's the final answer.